Okay, so now let's talk about cross-site scripting attacks. Now these are again, these are way more dangerous. So I think you guys are gonna have a lot more fun, and this is something that we're gonna go over a few examples on how dangerous they can be if someone's able to execute one of these attacks on a victim. And I'll show you some examples and then some ways to defend against it, as we've been doing throughout the course. So the first thing I want to do is I want to show you a very simple type of cross-site scripting attack. And I have, again, let's go over here to our bank. And what I'm going to do is I'm going to log in. Okay. And then what I'm going to do is I'm going to go to the very safe sounding URL called XSS. And then what I'm going to do is I'm going to click on this link. And then that's going to execute an attack for us. So as we can see, if we look over here on the URL changed from source. Let me close this. The URL changed from source to the fact that we're running a script tag. You can almost tell. And through that script tag, the user was able to get that person's session ID. So again, this is a different way, and then over here it shows the script that actually ran once I clicked on that link. So, essentially, just like we were looking at for cookie hijacking, with the cross-site scripting attack, there are two types. There's the reflected type, and then there's the stored type. But all that means is the following. Let's go over this for a second. So, as we were looking at for cross-site request forgery, what happens is that there's only so much that an attacker can do once they're not executing code on the user's behalf, right? So they have to get them to click a link or something. But if an attacker actually gets to run and execute code on the actual user's browser, then it really opens up the user or the victim to a lot more vulnerabilities. And so what we found out is that, when we weren't running code, we couldn't do these things. For example, like we couldn't cross the iframe boundary, right? So it became, there's ways to mitigate those attacks. But again, attackers have found different ways to get to run JavaScript on the page in different ways. And again, once you're running JavaScript on the page and you're not going through cross-site request forgery, then kind of everything changes hands. So let's talk about what is an XSS attack and how does it work. So essentially is the following. An attacker sends the victim some link, okay? Now that victim clicks on the links and requests a legitimate website. The victim's browser loads the legitimate website, but also executes a malicious script, okay? And that malicious script sends some victim data over to the attacker, right? So essentially all it is they're getting to run some script on your browser. So it's a code injection vulnerability that's caused when an untrusted user data unexpectedly becomes code, right? And we're gonna go over again some of those examples. So any code that combines a common with use data is susceptible. So anything that's user input. Again, we've talked about how dangerous it is to kind of trust user input. Well, again, in this type of attack, that's exactly what we're going to try to do. In cross-site scripting attacks, the unexpected code is JavaScript in an HTML document, or another way to for this to happen is an SQL injection attack, which a user through a user input, some type of form, right? They're able to submit a form. That form saves some code to a database, and then that database eventually gets executed and then shown to the user, and then that code that was saved gets sent to every client, right? So if the attacker gains some ability to do anything on the target, then they're essentially going to be able to get full access to the browser, and then at that point they can view, extract cookies, they can send HTTP requests, they can pretty much do anything, and it becomes really, really dangerous. So yeah, we just saw session hijacking with XSS. That's the attack that I showed you at the beginning. The attacker can insert their code into the web page. We saw through the URL, but really they can send a link. They can through a form. They can submit that form. That form gets saved, and then I'm going to show you over here on the server that I'm running right now through the request query resource. If when that form gets sent, so I'm going to go ahead and I'm going to okay, so I want to take you now behind the scenes just so you can see kind of what's going on. So I'm gonna go ahead and click on this, and I'm gonna go to the browser, and what you can see is that in the source, and again, this could come through a form, this can come through many ways, but essentially what's happening is that that over here, I'm just getting the source in the server, and then I'm not trying to defend against this attack at all. So the user can pretty much input anything they want, and what I'm gonna do is I'm gonna serve it directly into the page, right? So over here, I'm just serving that directly into the page, and then you can see it being executed. And then what I did is I showed what the execution was. So essentially, that attacker can send that information to their server and pretty much do anything else that that's possible through the browser. Now, let me show you the first defense against it. So the first thing that we can do to defend against it, it's there is this great package called HTML Escape. So if we go ahead, okay, and we come over here, and I'm going to comment this out, and then so we're still gonna get the source, but now we're gonna run it through the HTML Escape function through that package, and then let's see what happens this time once we run that code. So okay, continue. Okay, let me just go ahead over here. So now we're back, and let's click on that link again. So this time you saw that the alert was not executed, so the code was not executed, and we see that the actual code that I ran actually just gets printed out as a regular string. So that's the first defense, and I would say that, you know, if you're in the server code and you have any user input, go ahead and run it through an HTML escape function of some kind. There are many packages, but again, look for a package that does this for you. That way you don't run into any trouble. Okay, so let's see. Also, as I was making this, I was going through some of the, you know, I kind of wanted to get a feel for how prevalent are how prevalent are websites to these type of attacks. And as of as of 2019, this is still, you know, about almost half of websites on the internet have some type of cross-site scripting vulnerability that can be that can be attacked. So again, this is, if you're a developer, I would say this is probably your main concern, okay, when it comes to user input. Anytime you have comments, anytime you're letting the user input some data that you're later going to display back to other users, then that's a place where you should be on the lookout for this. And here are some. So if you're thinking that that a platform alone guards you from this, so we can see that infected websites by platform distribution as of 2018, pretty much every platform is susceptible to these attacks, especially the ones that allow you to install plugins. If you don't know what that plugin is doing behind the scenes, maybe you've implemented everything correctly, but now you've installed the plugin that allows for this type of attack, and all of a sudden now you're vulnerable again. So again, I would, anytime you have user input, I would try to control that yourself, and then that way you can guard against this. So again, why are these type of attacks so prevalent? Why are they the most prevalent? Essentially, is that data can be used in many different contexts. So the internet, like we've spoken about before, is this platform that at the beginning was not so not meant to be used for what it's used today. So the web has many different languages, right? So even within HTML, there are at least 5 contexts to understand, right? There's JavaScript, there's CSS, there's data, there's links, there is there's all these things that HTML has to somehow render. And when we're asking so much of the HTML parser, it essentially, and we're trying to accommodate all these languages and contexts, then it inevitably we run into this vulnerability. So if you just make, and again, remember, all you got to do is you got to make one mistake somewhere, right? So just one vulnerability, and essentially, especially in big apps, and at that point you can be completely compromised, right? So it's not like you need to you need to, again, all you got to do is make one mistake, right? And at that point, your website becomes vulnerable. So like I was explaining to you before, also, there are 2 types of cross-site scripting attacks. The first one is reflected, the other one's stored. The main difference is that reflected is essentially the attack code is placed into the HTTP request itself. So the attacker's goal is to find a URL. So either they're going to give you a link, or it's some link in some form or some place. And once you click on that link, then the attacker is going to try to perform that attack, just how we saw in the example. Now, the limitation of the attack is that the attack code must be added to the URL path or the query parameters, and also that the server has to be vulnerable to these. So they must not escape HTML. So sometimes when we're using, for example, if you're using any templating language, for example, like EJS, over here, the EJS allows you to escape HTML, and then at that point, we're not, if we use the equal sign, we're escaping it. If we use the minus sign, we're not escaping it. So another, templating languages that you're developing in probably have some, this feature itself beyond HTML escaping it. So, those are two ways that you should be on the lookout for in whatever templating language you're using. The other type of XSS attack is the stored type, right? So the attack code, when it's stored, essentially what the attacker is going to try to do is it's going to try to get the code persisted into the database, right? So for example, let's say you have a comment box on some, somewhere on your site. You have maybe some comments or testimonials or whatever, and then once the user, inputs their comments, whoever goes to that page after, later on, then all those comments are going to load. Now, if within those comments, one of them has one of these attacks, so if they were able to store some malicious code into this comment, then at that point, again, you become vulnerable, or the website becomes vulnerable to the cross-site scripting attack. So again, the attacker's goal when it's stored is use any means necessary to get the attack code into the database. Once there, the server includes it in other pages into the clients, and at that point, you're pretty much screwed. So yeah. So now let's talk about where, besides reflected and stored, let's talk about some of the places that you need to be on the lookout for that you might have not thought about before. Whenever you're allowing for a user to input some data that you're later going to serve to other users, right? So first of all, I'm going to show you in two ways. I'm going to show you first the HTML templates, and then I'm going to show you what are the ways to fix this. So let's say you have a website and you want a user to upload an avatar, or you're letting them upload an avatar yourself through a link, right? So again, if you have image source avatar.png, and then even in attributes, so the alt attribute, the user can input anything they want there, then that is a place where, and I'm going to show you some examples now, where a user can essentially attack, right? So this is user data here. So whenever you see that, whenever you're going to render some user data that they input and then you later render out, that's a place where vulnerabilities can happen. Now, what are another fix for this? If you're not HTML escaping, but even if you are, instead of using single quotes, change all your single quotes to an APOS. So that changes it to, on the server side, it'll read as APOS, but once it gets rendered to the DOM, then the DOM will render it back correctly into a single quote or double quotes. Now, if you want to change your double quotes, you change it to ampersand QUOT : okay? And that's a way, another way that if you have user data to defend against it. Now, what about HTML attributes without quotes, right? So again, we have the image and the URL here. Now, let's say we have, again, we're allowing a user in this example to maybe load an image themselves, right? Or maybe they have a comment box, and in that comment box, you're allowing them to include images. Now, if you allow them to include images, maybe you're saying, okay, I've escaped the single quote, right? So because we know that when they're using single quotes, they can essentially include something like JavaScript. Well, also, when the thing about HTML attributes is that HTML attributes it's not necessary for you to include single quotes in order to execute the HTML attribute. You can also include HTML attributes, and this is just, again, part of the HTML spec, as without quotes. Now, the thing is that if you do it without quotes, then you can have no spaces. So as soon as you have a space, then it gets treated as another attribute. But if a user, for example, does this, like unload equals alert, parentheses, document.cookie, parentheses, that's valid HTML, and then that would also get run as code. And again, there's no defense. There's no defense, as we were like seeing over here, that you can change all single quotes or double quotes into HTML escape characters. So over here you're kind of again in trouble, right? So unquoted attributes can be broken out of, right? So even if you have attributes like this, then again, there are many ways that attributes can be broken out when the DOM is parsing these attributes. For example, here are just a few that can cause troubles, and HTML will still try to parse the page. But again, the best defense against this is use an HTML escape package or a platform that does this for you, right? So again, beware of HTML attributes with special meanings. These are the most dangerous ones. For most attributes, escaping attributes is enough, like we said. If you use a package, you're usually in the clear. If you're allowing users to input something and you're escaping that input, you're usually in the clear. But again, beware of certain attributes like source attributes and href attributes, because these carry a heavier weight when it comes to the DOM, and the DOM again gives special meaning to these attributes. So let's say you have script source, and then you have some user data there, and right, that can never be saved even if you escape the attribute, because you're essentially allowing the user to because they're using the script tag and the source. At that point, you're letting them load in any random JavaScript, and then it'll just run in the browser. So if you're doing something like this, again, there's really no defense against this. Just be wary. When you're doing this stuff, ask yourself, is it really necessary to load in an external script? And if you do find that it is necessary, then figure out, go through that code and figure out where specifically, through some of the stuff that we've learned about in the class, where specifically you might find some vulnerabilities. All right. So also watch out for data and JavaScript URLs. And maybe for some of you that have not seen that before, let me show you what I mean by that. So there is this, and again, this is just part of the HTML spec, but most people don't even know that this exists. You can essentially write a link, that's valid HTML, and call it data :text HTML, and then pass it some h1, and then that actually will get parsed and rendered as regular HTML. And then let me just show you over here. So if I'm just gonna open this in a new tab, and as you can see over here, that URL doesn't start with www, right? www. It starts with data, and then what we're doing is we're essentially treating it like an HTML document, right? So we have data text HTML, and then we're saying this is the HTML I want you to render, and again we see that it gets rendered as regular HTML, right? So if someone gets you to if an attacker gets one of your users or a user to to click on a link, and the link is structured in this way, then that's a potential way to execute some HTML data that you might have not even been aware of that was possible through the href tag, right? The other one, it's a bit more common, and most of us are aware of this. But in the href tag, you can also include JavaScript as instead of www. So again, href is not just www. HTML will recognize these and actually execute them, and then we can execute any JavaScript code, and it's, at that point, again, you're pretty much right. So I just clicked on a link, and that link opened up a text box with the text hi. But you can essentially with what we've learned about, at this point, the user is pretty much screwed, and if there's no defense against this, then you can have a leak or anything at that point on your site. Okay, so what are the data and JavaScript links? Again, I just show you. This is how they're formed. So again, just be aware of this whenever you're allowing someone to input a link on your site that you're later going to render. And then let's go over also some other danger scenarios, right? So let a user choose a URL. So again, I'm going to go over 3 scenarios here that again, if you're taking notes, I would say these are the writer downers. Write these down, because anytime I usually have a checklist when I'm writing code, and I want to check for vulnerabilities. It's kind of having like a pilot when they have a checklist, or like a pre-fight checklist. So before you deploy your code, make sure you go over these things. Again, it'll serve you well. And remember, all you need is one mistake, and then you're pretty much screwed. So anytime you let a user choose a URL, get JavaScript, essentially you're allowing them to get JavaScript execution, right? So Anytime, even if you're just allowing simple links, you're saying, yeah, but I'm not including, I don't let any JavaScript be included. So any script tags, essentially, is what I'm talking about. Well, anytime they have access to even a link in the URL, they can essentially, the href attribute, then that means that they have access to the JavaScript execution at that point. Anytime you let users, obviously, iframe, right? So including an iframe, at that point, of course, they have access to the JavaScript execution. And anytime you let, obviously, a user just load a script tag, through the source attribute, again, you've given them access to JavaScript execution, and then at that point, you are pretty much you screwed. So one last thing about attributes. So now we're gonna talk about different ways that you might have not thought of, that are not just simple use cases. And again, remember, attackers have all day to think about this. Okay, so you got to be aware that they're gonna come up with interesting and creative ways to bypass even even things that the browsers and the specs try to cover. But again, the web is just too big, and these things are something that it's on every single one of us as developers to be on the lookout for. So let's say you have something that is on mouse over, and then you're executing some function, and then within the handle hover function, you're gonna have some user data there, right? So this could be whatever, right? So on mouse over, you want to show maybe an image, or you want to show whatever, a chart, anything that's going to be essentially executed here. Well, if a user has access to the user data here, what they can essentially do is right here. So what they can do here is they can finish the function execution early with the semicolon, and then close it, and then run another function with any type of JavaScript code, and then again finish the string. And at this point, I don't know if you're catching over here. So anytime you let user data, if they if they can escape, so this essentially is going to be the user data. So this is where it ends over here. This is where it starts. So imagine if what they did is that this was their input, right? So their input is going to be the following, right? It's going to start with it almost looks like a sad face, right? So close parentheses, semicolon, and then their JavaScript code. So when the DOM sees this, what the DOM is going to do, the DOM is essentially going to say, okay, so this is the end of the handle hover function. Great, perfect. Then this is another function, and the DOM is not going to know the difference, right? So the DOM is just going to then execute this as regular JavaScript as if it was intended, simply because you allowed the user to have, again, user input at this point. So again, something to be aware of, okay? So these are the little things that you need to just, catch and try to run certain scenarios before, at least on places where you're allowing this user input. So again, here's another example. Let's say you have something like this, right? So let's say on your website, you have let username equals user data here. So their user, right? So you're allowing their user to pick their username. Again, completely normal website behavior, right? And then what you're going to do is you're going to render it out somehow, right? So it's going to say hi there, and then you're going to render out their username. Perfect, right? Sounds good, all good, no worries there, right? So what if the user does this, right? So what if the user, when they enter the username and then they store it? So again, now we're talking about stored XSS. What they stored is the following. This is going to be their input. Their input is not going to be just a simple name. This is going to be their input right here. John, close the quote, then semicolon, and then they're going to execute some JavaScript code. And again, once this gets run, this part over here is going to get run like regular JavaScript, right? Because we are not escaping it, and we are going to render it out to the page. So the DOM is going to say, hey, you know what? This change, this after this closing of the quotes, and then the semicolon, that means that's a valid variable. Anything after that, now that's just, again, regular JavaScript. And since we're executing JavaScript at this point, then it's going to treat it like JavaScript, because again, we had an early execution of the JavaScript, and then because of the malicious code, then this piece again allowed it to run the JavaScript, and it became a vulnerability. So again, what are some of these fixes for this? I would say the most obvious one is use a package that will allow you to do HTML escape. Make sure you're using a platform that allows for this. But again, change all your single quotes to you should just write a function that changes. And again, there are packages for this, but if you're not going to use a package and you want to write it yourself, at least do this, right? Change all your single quotes to ampersand APOS semicolon, and change all your double quotes to ampersand QUOT semicolon. And again, that's at least mitigates a lot of the vulnerabilities. Let's go over another example. So again, same thing on the top, right? So you're gonna allow some username. You're gonna allow the user to just pick their username essentially, right? But then again, let's yeah, this is crazy. So let's say this is what they choose as their username, right? So what they're gonna do is they're gonna escape the JavaScript execution for themselves, right? So they're gonna say, hey, you know what? This is my username. Within my username, they're gonna escape your current running JavaScript execution, and then they're gonna create their own JavaScript execution context, and then run it, and then at that point start the JavaScript execution again, so yours can start again. So again, what happens? Then what the DOM's gonna see is DOM's gonna say, okay, that this is where we're finishing one JavaScript execution. Now we're starting a new one. So again, it's like loading a new JavaScript code from externally or internally, but again, they just did it themselves. And then they're gonna go ahead and then continue your JavaScript execution to continue. So then there is no, from the DOM's perspective, there is no essentially no syntax error or anything, right? So this is gonna run completely fine. And then when you render this, hide their username, then what's actually gonna get executed is the alert document.cookie. It becomes a vulnerability, right? So what's the fix for this? So another fix to bypass this, it's again, there are libraries for this. So I suggest use a library, but I at least want you to know what the defenses are, so you can at least be aware of them, right? So you can hex encode your user data to produce a string with characters from 0 to 9 and A through F, included inside a JavaScript string. So anytime you have user input that's a JavaScript string, go ahead and hex encode it. What you will then have to do is that you would then have to decode it as well. But again, there are libraries that can do this for you, that can automate all this, and at least you don't have to worry about it, and you're at least writing safe code when it comes to XSS vulnerabilities, right? So again, inside the string, you hex encode it, and then once you are going to actually render it out, you hex decode it, and what that will do is it will turn all your strings into valid and safe HTML, right? So go ahead and that's another defense for this. And one last thing, for fix for script elements, there's this new HTML tag called template tag to store data that won't visibly render. So you can use that. And the escaping rules, again, remember this. They're simple, and the same for HTML elements, just HTML encode, and then again, look into it. Here's an example, right? So you get the template, right? Username, HTML encode user data here. So essentially, what this tag does for you is it does the safety check for you. And then all you got to do is, let's say you want to render out that username, you're going to go ahead and get document like element by ID. You're going to get that element. And then all you do is you get the text content from it. And because it's inside this template, this template tag, then that will be safe to then do anything you need to do with that data, right? So even if you're going to store that data later on in in your server and then render it out again, if it's coming from a template tag, which later on gets sent to your server, then at least the template tag can shelter you from some of these attacks. Okay, so anyways, I hope that was helpful. Those were that's what cross-site scripting is. We're gonna go a little bit more into detail here in a few more in the next presentation. But again, write these defenses down. Now you know what some of the attacks are, and yeah, see you in the next one.